All right, so let's get started. So before we start loading our dataset and start performing some analysis on it, the first thing we actually have to do is to make sure that the various libraries that we need are being imported. All right, so in this case, I'm going to use PyForest. And as I said in the introductory video, PyForest will actually help us to import all the libraries at once without needing to import them one by one. All right, so I'm going to start with from PyForest. All right, from PyForest import. And by the way, if you don't have PyForest, you can start by installing it. All right, so you do pip install. All right, pip install PyForest. So if you don't have PyForest in your Jupyter notebook, you do pip install PyForest. All right, I already have it, so I'm not going to do that. So let me comment it so that when you have the Jupyter notebook, you can easily run it. And since I have it, I'm going to use from PyForest import, and I want to import everything, so I will use star. All right, if you're a little bit familiar with SQL, I hope you understand this one. I mean, star means import everything. All right, so in order to see which libraries that we are able to import, I'm going to use lazy imports. All right, lazy import, and as soon as I run this, you can see over here clearly the various libraries that we've been able to import in the likes of Seaborn, Pico. I mean, a lot of them here, right, which we don't actually need to be importing them one by one. All right, so after that, we can now load our data set. So I will store it in a variable called df. All right, so df equals since we have pandas now, I'm using pd.read underscore CSV. Our data set is actually in a CSV format. All right, so I'm going to use read underscore CSV, and I'm going to load it. Banknote underscore authentication. All right, authentication.csv. This, as I said earlier on, this dataset is actually available on Cargo and also on UCI. So if you head on to UCI, you can easily get it. And I'll also upload it on the platform so that it will become handy for you to easily download and start working on it. All right, so let's run it, and done. So now if I do df.head, all right, we can actually see the first 5 rows. So this is our data set, and this is the kind of data that we're going to work on. And if you can see here, this is a bit different from all the other data sets that we've been working on previously. All right, this one, instead of maybe having the attributes that we used to work on, which if I show you the one we work on for the breast cancer, you can see we have clamp thickness, size, uniformity, shape, uniformity, something like that, so that we have a target here, and then we use all these attributes to predict it. Now in this case, right, if you can see over here, in this case we have is different. We rather have variance, we have skewness, we have ketosis, we have entropy, and then class. All right, it's a bit different. Instead of having the normal attribute, we have the variance, the skewness, the ketosis, and the entropy. All right, so we need to be careful with this kind of data set. And we have our target here, which is called the class. All right, so if I print everything here, right, we can see that we have some zeros and then we have ones. All right, so this is what we are going to predict. We are going to use these features that have been given to predict this class. All right, we're going to use these features to predict this class. So this class consists of 0, where 0 represent the banknote being fake, and the 1 represent the banknote not being fake. All right, so we're going to predict with these attributes whether a banknote is fake or not. All right, so let me just limit this to just the first 5 rows, right, so that we have space to work on. All right, so now we can check the shape and then see how many rows and how many columns that we have here. So we can see that we have about 1,372 rows with 5 different columns. All right, we can also, since the target is since the class is our target, we can also see the distribution of the zeros and the ones in there. All right, so let's use df, and then in df we select the class. All right, we're going to select the class, and then we do value count, value underscore count. All right, so if we run this, we can see that we have 762 zeros, and then we have 610 ones. All right, so this is a bit fair distribution. So this is an important step for you to know whether your data is having data imbalance. All right, where let's take it for instance, if we have, let's say zeros were equal to say 762, as we see over here. All right, and then 1 was equal to say 100. All right, then if we build algorithm for this kind of data set, then our model is actually going to end up predicting this is going to end up predicting zeros, since zeros are actually dominating. All right, and ignore this is going to actually ignore this and end up predicting more of these zeros. All right, so this is an important step for you to know whether your data is imbalanced or is balanced. Right, and if it is imbalanced, then there are several ways of there are several ways of dealing with it. You can actually use the up sampling. All right, you can use up sampling, or you can use down sampling. All right, there are several ways that you can deal with that, but in this case our data set is quite okay, so we're not going to do that. All right, so we can also see or check to see if there are any null values in there. So we can use isNA. All right, isNA. Can use the isNA function, and if we do this, we're going to have a lot of true or false in there, and the caveat is that it's going to break over here, and we will not actually be knowing whether there are some truths in here. Right, we can do a quick eyeballing here. In this case, we have 1372. All right, so if we get a break here, we will actually not know whether there are some true. If this false, then it means that there's no null value there, but if it's true, then it means that there are some null values in here. Right, but it's quite difficult to spot it. So I can also do .sum. All right, I can also do .sum. Then this will become a summary of, this will give me a summary of all the columns, and see if there are any true there, then it will be it will start to count how many truths are there, but if there are no truths, then it will return 0. All right, so this is also a good way of checking if there are null values in there. We can also check the data type, right, by using D types. All right, by using D types, we can also see the data types that we have. Sorry, it's not a function. D types. All right, so now if we do D types, you can see that we have float, we have floats, and then accept the class that we have it to be int, so we can easily quickly eyeball it and see that okay, we have float, and then this is integer. So everything is fine over here. Right, sometimes you might end up seeing it as maybe as a float or as an integer, but sorry, but when you check the data types, all right, when you check the data type, instead of presenting you with integer, it will present you with an object. Then you get to know that there's something present in that column which is causing it to be an object. Different people have different ways of representing, say, null values, right? Some represent it with a question mark, and if your data set is having a question mark in there in a certain column, let's say this is supposed to be an integer, right? But if there was a data which is missing, and the one who collected this data represented the missing data with a question mark, then instead of this column being an object, being an integer, it's going to be interpreted as an object because of that question marks which are present in there. All right, and there's a different way. There are several ways of dealing with that. All right, so checking the data type is a good practice to get to know whether what you're seeing is really what what is supposed to be there, because you have in this case we have 1372, so we cannot actually see every data point here. All right, so you are seeing the first 5 row, and maybe you're convinced that it is an integer, but if you check the data type, it might actually give you different data type. All right, but in this case it's okay, so we are fine to go. So let's try and do some visualizations. All right, so let me convert this to a markdown, and then we'll be doing some visualizations here. All right, so let me make it a little bit bold. All right, okay, good. Let me bring it down a bit by using that. Okay, that's good. Now we can, since the class column is actually our target, we can actually see with this distribution that we check, we can actually visualize it and then be more convinced of what we are seeing is what is actually what is supposed to be distributed. All right, so we're going to use the seaborn, and don't forget we've already imported it using the PyForest. All right, so I'm going to use SNS. All right, I mean, when we import the seaborn, we shorten it to SNS, so I'm going to use sns.distplot. I'm going to use distplot, and then in df I will select the class. All right, I will select the class, and then I can set color to say red. All right, and I can also set title, so let me put plt from matplotlib. All right, plt dot title. All right, so in this case I can give it distribution. All right, distribution of, let me put it in quote, distribution of class. All right, distribution of class attributes. I think this is fine. Okay, I can let me just run this and see if everything is okay. Okay, model seaborn has no attribute distplot. Okay, we missed T. Distplot. Okay, good. If you want to manipulate the size, you can actually control that by using the matplotlib figure. All right, so you can do plt.figure, and then you can set the fixed size. All right, so for setting the figure size, you can use fixed size equal to, and then you give the length and the width. So maybe in this case we can give 10 and then 7. All right, you can see that now it's very big. Right, it has become a big one. Okay, you can control that with that. Now you can actually see that we have some zeros in here. All right, we have some zeros here. Here's the 0, and then here is the 1. All right, so the 0 is actually a bit above of the 1. All right, if we check the distribution, I mean the 0 is the 1 is a bit less, but 0 is a bit higher. But if you see the KDE, right, the kernel density estimate, you can see that it's uniformly distributed over there. All right, uniformly distributed for both of the different classes or the different categories. All right, so we can also see we can also use the histogram to visualize each of the columns. So in that case, I can use this our df, right, and then I'll use histogram. All right, and I can set the bin size. So I can use this. Maybe I should just give it 20. All right, then I can set the fixed size. So here I'm setting the fixed size inside instead of going to set it up there. And probably I can give it 15.8. Then the layout of each of them, I can give a layout of each of these, maybe 2 by 3. Needs a bracket. All right. So let's see what happens over here. Okay. So let me try and get rid of all these. Just putting this there. Awesome. So now we can have a visual representation of all the various attributes, all right, or the various columns. So this is the class, and this is just the same thing over here, with the exception of the KDE not being there, all right. And then we have the kurtosis. You can see that it is positively skewed here, with this negatively skewed here, but with the skewness and the variance are almost uniformly distributed. All right, so this is quite okay for us to move on. All right, this is quite, and if you see the data set that we're working on, all right, with this variance, the skewness, the kurtosis, and the entropy, it's actually okay if you don't check the correlation between each of these, because this is variance and skewness and kurtosis. It's a good practice to check, but if you don't check it, it will not actually harm you like that. You can actually use the pair plot to have a visual representation of this. All right, so let me do that one instead of maybe using the dot call. All right, I'm going to use the pair plot, which will actually give us a visual representation. So I'm using sns.pairplot, then I'll pass in my data, which is df. All right, I can set say hue equals say class, so that I will be able to also visualize the class alongside. All right, and using different colors, I will be able to see different attributes on the same plot. So let's run this. Take a little bit of time, but it's still going to give us an answer. So this one is giving us some warnings here. All right, it's giving us some warnings here. Evaluate blah 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 blah. So I can just ignore this warning by just let me add. You can just ignore this warning by just importing. Just import warnings. All right, you can just import warnings, and then I'll use warnings. All right, warnings dot filter warnings. All right, I can use that, and then I'll ignore it. All right, let's run that. Good. Now let's run this again. Taking a little bit of time. Now you see the warnings are not coming. All right, it's taking a little bit of time, but it's because we have, now you can see that the warnings are not coming, and then we have a beautiful pair plot over here that we can actually see. Okay, so in this case, if you see the diagonals, all right, this is a kernel density. It's just the same thing that we see over here, but it's filled here. All right, and now if you can see here, we are having some two peaks. All right, so we use hue, right? We use hue because class, so that we can actually see the class alongside using colors to differentiate that with respect to the class. All right, so if you can see, we have two peaks here, right, which is giving us a signal that we might have, we actually have, not that we might, but if we see on our class column, it's either 0 or it's 1. All right, so we have two classes in there. All right, so this one is actually giving you that kind of signals. If you're doing something like classification, clustering, this is a good way to actually get a hint of how many classes or how many clusters you're going to actually end up with. All right, and if you see the various scatter plots here, you can see that the correlation here is very poor. All right, it's very poor. Some are a bit positive, but it's very low. It's very low, right? Low, very low, positively correlated. All right, and some are negative, a bit I mean moderate, negatively correlated, and some are curvilinear form. All right, so this is a better way of viewing it, instead of maybe doing the correlation plot, the correlation matrix. All right, so in this case, we will move on to start preparing our data, all right, for building our model.